All right, here we go. Today we've got 9.6 notes solving using laws of logarithms. So one of the nice things about this set of notes is there's not really anything new that we're going to learn. We're just going to take the stuff we applied in 9.5 and use that to help us solve equations, which we've been doing since 9.2. Here, like I've mentioned before, we're really only going to see two types of problems. Okay, we're going to either have logs on one side of our equation only, in which case we want to put it in exponential notation, or we're going to have logs on both sides of our equation, in which case we first want to get it down to one log on each side, and then we can ignore the base and set the other parts equal to each other as long as our bases are the same. Okay, so those are the only two types of problem we're going to do. Again, nothing really new. Let's just dive right into the examples. We can probably zoom in a little bit. All right, so first one we want to solve for x. Okay, well, I've got logs on both sides of my equation, so then can I ignore the log and the base 7 part and just set the other parts equal to each other? Well, not yet. I can do that when I have log base 7 of something equals log base 7 of something. But since I've got two logs over here, first I want to combine these two. So the left side of the equation is fine. We're going to leave that alone for now and leave it as log of x minus 3 base 7. And then that's going to equal, now I want to combine these two logs into one log, so we'll start by writing log one time. Our base isn't going to change, so that's base 7. And then since I'm subtracting my two logs, so think back to your exponent rules, what other property goes with subtraction? Well, division. So I want to divide these two numbers. Now it's not always just biggest divided by smallest, it's always the first thing divided by the second thing. So then this is going to be the log of, and you can normally do this part in your head, but I'm just going to write it out, 10 over 2. Okay, and then we can simplify that. So we get log of x minus 3 base 7 equals the log of, this is going to give us 5 base 7. All right, and then now that I have log base 7 of this thing equals log base 7 of that thing, well, now we know this thing has to equal that thing. So then we get x minus 3 equals 5. And then if we just add 3 to both sides, we get x equals 8. And then that's our answer. Okay, so again, nothing really new here. We just got to get our equation looking how we want it, which usually means we're going to combine some log statements. All right, let's go right ahead to the next one. Similar problem. We got 2 times log of 7 base 8 equals log of x base 8 minus log of 3 base 8. Okay, so here, obviously like last time, we want to combine these two logs. And then I also, I want it log base 8 of something equals log base 8 of something. So obviously we have to combine these. But I also want to get rid of that 2. So we got to use another rule here, our exponent rule. They're kind of doing it backwards though. I want to take this number in front and I want to put it back in the exponent. And then I also want to combine these two logs. Okay, so putting this back in the exponent is going to give me the log of 7 squared base 8 equals, and then here again I want to combine these to one log, so do it one piece at a time. Start by writing the log, and then it's going to be base 8 because my base isn't going to change. And then, well, again, since we're subtracting these two logs, what do I do with the x and the 3? I want to divide them just like last time. It's always the first thing divided by the second thing. So this is going to be the log of x over 3. Okay, and then this time, well, we don't need to simplify this part. We want to simplify this part though. Okay, and in fact, we can even do that as we write our next step just to save a little bit of writing. I got log base 8 of this thing equals log base 8 of that thing, so I know this thing has to equal that thing. So I get 7 squared, which is 49, so we're just going to write 49 to save a little bit of writing. I know 49 equals x over 3. Okay, and then I don't want x divided by 3, I want x by itself, so the opposite of dividing by 3 is multiplying by 3, so I want to multiply both sides of my equation by 3. And then those are going to reduce to 1, so those go away. And we just get x by itself, which I'm going to write first, equals 3 times 49, which is 147. And then that's our answer. Okay, so again, hopefully these aren't seeming too hard. We just got to use the rules to get our equation looking the way we want it to before we can solve. All right, let's move right on to the second page. Hopefully this will be a fairly short video here. All right, next example, solve for x. Again, so very similar problem. We've got 2 logs on one side, 1 log on the other. I want to combine these two things, and then I could ignore the log and the base and set these equal to each other. All right, so we got 1/2 times the natural log of 9 plus the natural log of x equals the natural log of 18. And remember, natural log just means log base e, but really that's not even going to matter because once I get the natural log of something equals natural log of something, well, I can ignore the whole natural log part. So we never even have to deal with any kind of base e. Okay, but first, we need to do a few things. First thing we need to do is get rid of the number in front of this natural log. Nothing else has a number in front, so I just want to take this and put it up here as the exponent to 9 there. So then this would be the natural log of 9 to the 1/2 power. Now let's save a little bit of writing here. What is 9 to the 1/2 power? Well, that's the same as the square root of 9, which is 3. So I get the natural log of 3 plus the natural log of x equals the natural log of 18. Okay? All right. So good. We got rid of that number in front. Now I want to combine these two logs. So the natural log of 3 plus the natural log of x. Well, how do I combine these two things? Well, when I'm subtracting, I divide. When I'm adding two logs, well, then I want to multiply these two numbers. So this is going to be the natural log of 3x equals the natural log of 18. And now that I've got the natural log of something equals the natural log of something, well, now I can ignore the natural log part. Again, I don't cross them out. I don't cancel them. You know, we don't divide by a natural log. That's not a thing. We can just ignore the natural log part because I know that this part has to equal that part. I know 3x has to equal 18. So to divide both sides by 3, we get x equals 6. Okay, so then there's our answer. All right, moving right along. Next one, solve for x. Let's get this scooted up. We got the log of 2x plus the log of x minus 5 equals 2. Okay, so this time, and this is, I don't know why there's not more examples like this. Anyways, this time we only have logs on one side of the equation. Okay, well, like it says on the front page of the notes, we solve that by putting it in exponential notation. But before I can do that, I have to combine these two logs here. Okay, well, just like the last one, since I'm adding these two logs, I want to multiply 2x and x minus 5. And that's going to be, and we'll show our work here, the log of 2x times x minus 5. And then it's base 10, and we don't need to write the 10, equals 2. All right. Now, since we've got it down to one log, yes, we do want to distribute this, but we can go ahead and put it in exponential notation and distribute that in that next step. So my base is 10, so it's going to be 10 to the second power equals this stuff. And since we got to square the 10, we'll go ahead and write it how it is. 2x times x minus 5. And again, that's the kind of thing you can probably distribute that and multiply it out in your head and not ever write this step. I'm just trying to show my work here. So then we get 100 equals, and then distribute the 2x, we get 2x squared minus 10x. Okay. Now we want to solve this equation, which now has become a quadratic equation since we have x squared in it. Okay. So there's a couple steps we can do first. The first one I'm going to do, let's set it equal to 0 because I know that eventually needs to be done. I'm going to subtract 100 for both sides. And then that's going to give me 2x squared minus 10x minus 100, and then equals 0. Doesn't matter what side the 0 is on. I'm going to stick it on the right side. Okay. All right. And then how do we solve this quadratic equation? Well, we can either factor it if it's factorable, or we can use the quadratic formula. We can complete the square. We got a few options. But before we do any of that stuff, well, how can we make this equation a little bit easier? Well, all three of these numbers are divisible by 2, including 0, so all four of these numbers. Let's divide everything by 2. So divide both sides of my equation by 2, which is going to divide everything by 2. And that's going to make my numbers smaller and get rid of that leading coefficient, which will make this hopefully much easier to factor if it's factorable. Let's go up here where we have a little bit more space. And then that's going to give me 1x squared minus 5x minus 50 equals 0. Okay. So here we are. All right, now, yeah, that thing's factorable. How can we factor this thing? Well, I know this trinomial is going to factor into two binomials, so we can write those down. To get negative 50, I got to multiply a positive number and a negative number. To get x squared, I know I got to multiply x times x. And then what multiplies to 50 and has a difference of 5? Well, 10 and 5. And then my bigger number is negative, because there's more negatives left over when we combine like terms. So negative 10 and positive 5 are going to be my factors. Okay. And then last thing, if I got this thing times this thing equals 0, well then when are these two factors going to equal 0? Well, when x is -5 or +10. Okay, so then we get these two answers of -5 and +10. Okay, now one thing you want to check, do both of those answers work? Okay, can I plug in -5, for example, into my original equation? Well, if I stick in -5, I get the log of -10. Can I take the log of a negative number? No, we can't. Okay, that's one of our domain restrictions. We can't take the log of a negative number. If I stick in -5 here, this would also be a negative number. So that's no good. Okay, so again, it doesn't satisfy our original equation, so then we want to ditch that answer. And our only answer we want is 10. Okay, so if you're dealing with negative answers, definitely make sure that they satisfy your original equation, because we might have some extraneous solutions like we did here. All right, moving on, last one. Keep this video nice and short. Now we got the log of 4x base 3 minus the log of x minus 7 base 3 equals log of 5 base 3. Okay, so I got logs on both sides of the equation, so we want to get it down to one log on each side of our equation, and then we can ignore the log base 3 part. There's no numbers in front, so that's good. I don't have to worry about my exponent rule. I just want to combine these two logs. Okay, well, I want to combine them to one log, so let's start by writing log one time. It's base 3, that's not going to change. And then since I got 4x here and x minus 7 here, well, that doesn't really matter, but since I'm subtracting the two logs, that part does matter. Then what am I going to do with the 4x and the x minus 7? Well, we're going to divide. And remember, it's always the first thing divided by the second thing. So then this is going to be the log of 4x over x minus 7 base 3 equals the log of 5 base 3. Okay, now don't worry that this is kind of an ugly looking thing here, but I've got log base 3 of this thing equals log base 3 of that thing. Well, then this thing has to equal that thing. So I know 4x over x minus 7 equals 5. Okay, all right, good. So we got rid of the logs. Okay, now how do we solve this equation? Well, first of all, we don't like having a fraction. Let's get rid of that fraction by multiplying by the denominator. So if I multiply both sides by x minus 7, and I do need parentheses there because it's a binomial, x minus 7, these are going to reduce. I get 4x on the left side equals, and then distribute to 5, we get 5x minus 35. Okay. All right, then last step, let's do two things here. I want to subtract 4x from both sides because that's going to give me 1x, which is good. And then since x is going to be on the right side, let's move the 35 over to the left side by adding 35 to both sides. And then those cancel, and I get 5x minus 4x is 1x equals, on the other side of the equation, we get 35. And then we're done. Okay. So again, we're just using our log rules to get it down to one equation on each side of our, one log on each side of our equation. If you have logs on both sides, then you can ignore the log in the base part. If there's only logs on one side of your equation, like this one example we saw, then we want to put it in exponential notation once we get it down to one log in our equation. Okay? And that's it for these notes.